This is the screencast for section 10.1, example 5. We're going to find the length of one arch of the cycloid. Alright, so looking at this cycloid first, its formula or parametrization is x equals a times t minus sine of t. So basically the same thing we've been working with, they just factored out a. And then y equals a times 1 minus cosine of t. Again, the same thing we've been working with, factored out a. And then a, of course, has to be greater than 0. Now, this cycloid, remember, follows the point on the circumference of the wheel as this wheel turns on the x-axis. Well, one full turn is 2 pi. Plus, you can also look at the x-axis here. We are looking for the length of a curve from 0 to 2 pi. So we want the arc length from 0 to 2 pi, and remember that formula is the antiderivative from 0 to 2 pi of the square root of dx dt squared plus dy dt squared dt. So let's find dx dt squared. So dx dt is going to be a times 1 minus cosine of t, and then of course we'll need to square that, so it gets a little messy. And then dy dt squared, well, the derivative of y is a times the sine of t, much cleaner, and then squaring that gets me a squared sine squared of t. So if we plug that back into the arc length formula, I get that arc length is the antiderivative from 0 to 2 pi of what we got for dx dt squared plus what we got for dy dt squared. Now I see that there's an a squared in both of these terms, so if I factor that out, I can take the square root of that and then put the a on the outside of the antiderivative. Then on the inside I have, let's see, 1 minus 2 cosine of t plus cosine squared, and that would be plus sine squared, which we know cosine squared plus sine squared is 1. So I'll really have 1 plus that 1, which is 2, and then minus 2 cosine of t dt. Which is great. That's much easier to take the antiderivative of. However, I'm just going to do this the quick way. That is 8. The antiderivative of this radical from 0 to 2 pi is 8, and then we were multiplying by a, so the arc length would be 8a. Then I'll try problem number 43, asks us to find the arc length, or one arch, of a Curtate cycloid parametrically by x equals 3t minus 2 sine of t. So the radius of our circle is 3, but we're looking at a point that's only 2 units away from the center of the circle. And then y equals 3 minus 2 cosine of t. So I know that I'm going to be finding the arc length from 0 to 2 pi, one full rotation of this wheel. And now dx dt is 3 minus 2 cosine of t, and then of course I'm squaring that, plus dy dt, which would be 2 sine of t, and then squared. Now I know you're probably asking yourself, why did I do that separately in the example, but then all inclusive here? Well, it really doesn't matter if you want to do your inside work separately and then plug it in at the end. This one just seemed to be a little bit less messy, so I could kind of do it all at once and just keep myself organized. There's really no rhyme or reason to it, sorry. Alright, so let's square each of those dx dt and dy dt. So dx dt squared plus dy dt squared. Now I see a cosine squared plus sine squared, but I've got that 4 in front of each of those. So I'm actually going to factor out that 4, and then I have cosine squared plus sine squared, which is 1. So now I have 9 plus 4, which is 13, and then still minus 12 cosine of t dt. And then I could evaluate that using my calculator or by hand, and I get 21.010 units.